the slope of that line is positive 2 over negative 1, so it's negative.
Yeah.
So, if it's negative, then that line is falling. So basically, you're putting a negative into something that's already negative. Like it's going to be a negative of a negative. So you're going to end up with a positive infinity here.
So,
yes.
A normal one would look like this or look like that?
Falling would look like this. This would be a negative slope.
Okay.
Positive slope would look like this.
Okay, so
sorry. Negative this way, positive.
So if the slope of the line is negative, but it's a negative infinity, it's a positive infinity?
Yes.
Because the negative was a positive.
Yes, because it's a negative of a negative.
Cool.
Yep. So like on this one, it was a positive because it's 1 over 1.
Mm-hmm.
So, and when I put in negative infinity, I wouldn't change the sign. It was positive infinity.
Wait.
So the slope would... Which way is the slope going on?
Because this was negative infinity. This line...
That's a positive slope, isn't it? Like, it's a positive line, whatever thing.
It is a positive.
Which way is the slope going on the one that we just did?
It's going to negative infinity.
Yeah.
That limit is x to negative infinity, so that would
So it
be
looks like this.
It's a positive slope.
Yeah.
Does the one we just did...
Oh, okay.
That's
Woo! I was really confused for a second. Yes. This is a positive slope because this is a positive...
It is.
Yeah.
So that means when I plug in negative infinity, it's going to be going down.
Yeah.
And this one would be a negative slope, so it's going to go this way. And when I plug in a negative infinity, a negative of a negative means that it's going to be going
Okay, so
up.
it's like the coefficient in front of the x.
Yes, that's exactly what it is. The leading coefficients. Good. Now that's a shortcut. You can always do that where you divide everything by x and plug in, and that will work.
What are you doing?
Oh, I thought you were talking.
No, it sounds like she's like slurping, and it's just her straw now that I see what she's doing, but I'm so confused.
Okay, so this time we have f of x equals, we have a rational function and we have a square root. And notice, here's our picture. And notice this is one of those lovely ones that actually cross the horizontal asymptote.
I hate these. I mean, you can cross like this. It can cross the horizontal, like you just can't cross the vertical.
Right, absolutely right. So it says, what is the one thing that you notice is different about the graph of this rational function versus the graph of the others?
There's two.
Yes, there are two different horizontal asymptotes, and the graph approaches one on one side and the other on the other side.
And negative one on the other side?
No, and the other one on other one, shoot,
Wait, negative 2.
on the other side.
I hate the way.
So that's basically saying it's crossing the asymptote. So, like here, I'm approaching it from the bottom. And this one, whoa,
You just grabbed the highlighter.
that was wild. And this one, I'm approaching it from this
But
side.
that's negative.
That's true. They're two different ones.
Oh, wait, you were talking about the horizontal asymptote.
Yes.
You said 1.
I said approaches one of the horizontal asymptotes. Sorry. Okay, so looking at the picture, what's the limit as x approaches negative infinity?
Not really anything.
Yeah, look at the red line.
-2.
Yeah, it's approaching -2.
I was on a whole different problem.
Fine.
What's the limit as x approaches infinity on the right-hand side?
2.
+2. Yeah,
So wait, will this happen if there's a square root on bottom?
yes. Can happen.
Can?
Yes. I won't say it will always happen because there are very few always in math, but
Except 2 plus 2 will always.
okay.
She's going to correct you.
Will it not always
So we're-
be 4?
Yes.
Okay.
So we're going to perform the same thing with the limits at infinity. So, and we're going to have to do this the long way.
Are we have to, plug infinity in?
So we're doing this, and we know what the picture looks like, but
So you know
you're not going to always have time to draw a picture or have the picture or whatever. You may not have a calculator where you can plug it in and figure out what it's going to. So you have to be able to do it this way. So there was a method. There was a reason to figuring out
Why did they do
do
that?
it the other way. Okay, so the highest exponent that's on bottom here is x squared, but it's the square root of x squared,
So it's X.
right? So really we're dividing by x. Now we know the square root of x squared is technically what?
X. Wait, what? Square
Your
root of
positive or negative x,
what?
right? So since I'm approaching positive infinity, I'm doing the positive x.
Ooh.
So that's because x is greater than 0. Over here, on this one, I'm going to do negative infinity. So I'll plug in negative x.
You'll divide by -x.
Yes. So the limit as x approaches infinity of 2x over x minus 2 over x over the square root
No.
of x squared over x squared plus 1 over x squared. Because it's all under a square root, so that's just x.
We're trying to make things.
Huh?
Okay,
We're trying to
what's
make
up?
things fancy.
Oh,
wouldn't-
yeah. I was supposed to say, why isn't that? You said something
Why wouldn't
canceling,
we-
and I was so confused.
Why wouldn't we use x?
Because it's under a square root. It's not x, that's
But-
x.
So it's not a true X
Would it-
squared.
Would it not be the square root of x on the bottom then?
No, it'd be the square root of x squared on the
Yeah,
bottom,
square root of x squared.
which is what this is. Because it's all under the square root.
Okay, so since it's under the square root, when it's
Mhm.
out of the square root, it's just X.
Right.
But when it's in the square root, it's X squared.
Right.
Okay.
So that's 2 minus 2 over x over the square root of 1 plus 1 over x squared. You okay so far?
Yes.
Yeah.
All right. Then we plug in infinity. So 2 minus 2 over infinity over the square root of 1 plus 1 over infinity squared.
So it's just a square root.
Yeah, anything that has infinity on the bottom, if it's a constant over infinity, goes to 0.
I don't like that.
I absolutely love that noise. Okay, so then it's 2 over the square root of 1, which is just 2.
I don't like that.
But you went,
I know, because I figured, I was like looking at it, I was like, how's this gonna work? And then I was like,
it
I
works.
was like, the answer must be 2. Yeah, I can't do what happened.
Woohoo!
I don't know if I'm happy with it.
But we plug in negative x on the next one?
Yes.
Yeah.
So on the next one, square root of x squared is the biggest one that's on the bottom,
Mm-hmm.
which is negative x because x is less than 0 because we're approaching negative infinity.
Okay, so how would we, right.
Okay. So we do limit as x approaches negative infinity of 2x over negative x minus 2 over negative x over the square root x squared over x squared plus 1 over x squared.
So the negative really doesn't matter in the bottom?
No, because it's x squared, which negative goes away.
Oh.
Would it matter if we put negative x squared?
Yes.
It would.
Because think about it, negative x times negative x is x squared. Because negative times negative is a positive.
Yeah.
So that's negative 2 plus 2 over x over the square root of 1 plus 1 over x squared. Ashley, you okay?
Yes.
Okay, just tired.
Yes.
I didn't know if that was tired or confusion.
They both look
Well, I know, that's why I was asking. So negative 2 plus 2 over infinity over 1 square root of 1 plus 1 over infinity squared. Which again, the infinity things go away and go to 0. And you end up with negative 2 over the square root of 1, which is 1. And lo and behold, you just get negative 2.
I was confused and I was like, she's gonna fix it, and then she fixed it.
Oh, well, good.
Yeah, I was like, why is it no longer a negative x? And then
Oh, okay.
I realized. And I was like, I'm tired. I'm like, if I look at it long enough,